Mr. Garb here with lesson 5.1, taking a look at questions 1 and 2 real quick here. They're asking us, how can the vertex of a parabola be used in solving real-life problems? Well, usually it's going to be in the shape of a parabola, either facing up or facing down. And if a, which is the coefficient in front of the x squared, if that's greater than less than 0, it's going to be facing down like this. And there might be a maximized problem. That'd be like maximizing profits. Or it could be the height of a ball that's being thrown in a path. Whereas this might be when a is greater than 0, then you can have an upward-facing function, upward-facing parabola, and it might be like a minimized cost. It's typically where it's used outside of class. Now they say, well, why can a not equal to 0? Well, if a is not equal to 0, then if a is equal to 0, this whole thing is x squared, all right? And then you just have bx plus c, so that's kind of that's a line, right? So that's linear. So linear would be like this if a were equal to 0. So that's why a cannot equal 0. All right, number 3 asks us to find the vertex form and the vertex of the following quadratic. Well, in order to get that, vertex form looks like this, by the way, where f of x equals a, x minus h squared plus k. Well, in this case, there's no number before the x, so it's a 1. But the vertex form, so it's going to be a, in this case is 1, x. Now, h, just so you know, h you get from doing negative b over 2a, and k you get from doing f of h, finding f of h. Okay? So negative b over 2a in this case is, negative b over 2a would be 12 over 2. Okay, so h, this means h is going to equal 6. Okay? So we're going to have f of x, in this case a is 1. 1, so it's x minus 6, and then you plug 6 in to the original equation to find out what you get for k. So you put 6 in here, you're going to get 36 minus 72 plus 4, which gives you a negative 32. So therefore, it's f of x equals x minus 6x. F of x equals 1 times x minus 6 minus 32. That's the vertex form. So the vertex, therefore, is 6, comma, negative 32. Don't forget the formula has a minus in it, so the x-coordinate is not negative 6, it's positive 6. That's the way the formula is written. And most of the time, you're going to have a quadratic that does not that has an a that's not equal to 1. So here a does not equal to 1. But again, we're looking for f of x is equal to a x minus h squared plus k. And remember, h is equal to negative b over 2a. So in this case, h is equal to negative 4 over 6, which equals negative 2/3. All right, so we need to find our k now. Now k is going to equal to f of negative 2/3. That means we put negative 2/3 into this original equation. And we're going to get 3 times 4/9 plus 4 times negative 2/3 plus 1. So that's going to give us 12 over 9 minus 8 over 3 plus 1. You have to change that to ninths. So it's going to be 12 ninths minus 24 ninths plus 1. So it's negative 12 ninths plus 9 ninths, which equals negative 3 ninths, which is negative 1/3. Okay, so k is equal to negative 1/3. So therefore, our vertex form is f of x is equal to a, which was 3 times x minus negative 2/3, okay, which can become x plus 2/3 squared plus k, and k is negative 1/3. So that is our vertex form, and therefore our vertex is simply going to be h comma k. We just fill in the numbers we just got. So h was negative 2/3 and k was negative 1/3. All right, moving on down. These two problems ask us for, do these quadratics have a min or a max? Does it look like this, or does it look like this, like we did at the beginning? Okay, up here. So when we did in the beginning, we said, does it look like one of those two? It's in a min or a max way. So when we go back down here, what we're going to see is if a is greater than 0, you see in this case, In this case, we have a -4, so a is less than 0, so that's going to be a maximum. It's going to look like that. So we're going to have a max. In order to find that max, we would find the y-coordinate. So we know that x is going to equal to -b over 2a. It's called the axis of symmetry. Okay. So we have -b, which is -20 over -8, and that's going to give us that's going to give us 5 over 2. Okay. That's the x-coordinate, but the actual max is what you get after you plug this in. It's looking for the k value, essentially. So we have to put 5 over 2 into here. So we're going to get -4 times 5 halves squared. Okay. -4 times 5 halves squared plus 20 times 5 halves plus 5. That's where that answer is going to be our max. So it's going to be -4 times 25 over 4 plus 50 plus 5. And so that's going to give us 25 plus 50 plus 5. And that's going to give us 80. So this problem is going to have a max, and the max is 80. It's the y value that we're looking for. Okay, the y value. So in this particular case, a is greater than 0, so this is going to be an up-facing parabola, so it's going to be a minimum. And we need to find the y-coordinate of our vertex, or the k value. So that's going to be negative x is equal to -b over 2a. So therefore we're going to get -13 over 10. We have -13 over 10, and I have to plug that in for x over here. So we're going to have 5 times 169 over 100, plus 13 times -13 over 10, minus 9, and whatever we get there. So we're going to get whatever that is, 169 over 20, plus, that's going to be minus 169 over 10, minus 9. So what will that be? That would be 169 minus 338 over 10, over 20, sorry, over 20, minus 9, which is like minus 180 over 20. So we're going to get a negative value. 169, that's negative 169, negative 349 over 20. It's going to be negative 349 over 20. Okay, and that's how you do it. Okay, so these two problems ask us to find the vertex and the mins, the max intercepts, domain and range. So we start with getting the axis of symmetry. So again, x is equal to -b over 2a. And so that's going to be -10 over 2. So we're going to get x is equal to -5. That's the equation of the axis of symmetry. Okay. And then we get the vertex. Well, we have to plug that in to get the y value. So plug in -5 squared. Okay. So we're going to get 25 minus 50 plus 24. So that's going to be a negative plus 24. It's going to be -1. Negative 25. Yeah, plus 24 is -1. So therefore, our vertex is going to be -5, -1. And our y-intercept is when we plug in is x for 0, and we're going to get 24. Our x-intercept is when we plug in y equals 0. That means we have to factor that guy, and it's going to be, are we going to be able to factor that? Well, 6 and 4. So x plus 6 and x plus 4 equals 0. So you're going to get -6, -4. Those are our x-intercepts, so it's going to be -6, 0 and -4, 0. Those are x-intercepts. And then our domain is going to be, well, since this is a minimum function, it's going to look like that. Our domain is going to be everywhere. Okay, all real numbers. -infinity to +infinity. And our range is going to be from a minimum point everywhere up. Well, the vertex was -1, so it's going to be from -1 to +infinity because it's a minimum function. Okay, that means it's going to be facing up. Now this one down here, we're looking for where's the function increasing and decreasing. Well, we need to find that x. We need to find that turning point. So we're going to have x is equal to negative b over 2a. So b is actually 0, so it's going to be 0 or negative 4. So therefore, we're going to have x is going to be 0 for our x-coordinate of our vertex. We plug 0 back in, and we get 0 minus 1 equals negative 1. So therefore, 0, negative 1 is our vertex. So where is it? So that means when we have a graph, and 0, negative 1's down here, and that's going to be a facing down function like this, okay? Because a is less than 0 here. So therefore, we can tell it's increasing from here, from negative infinity up until, right? From negative infinity up until 0. See? Okay, and then increasing, y is increasing from, y is decreasing from what? 0. Yeah, that's from 0 to positive infinity. Okay, so everywhere when x is everything greater than x, y is decreasing. And does it have a min or a max? Well, it's going to have a max because it's right here. And the max is at 0, negative 1. The domain is anything, negative infinity to infinity, because x could go anywhere. And the range goes from negative infinity up until including negative 1. That's how you do those. Now, the next question gives us the vertex is 2, 7, and they give us a point that the quadratic goes through, parabola. The shape's called a parabola, by the way. So they're asking us for the equation. Well, we know that y equals a times x minus h squared plus k is the vertex form. So since they gave us the vertex, it makes sense to use the vertex form. So if we plug in the information we know it's going to be x minus 2 squared plus 7. We just have to fill in that a. Well, we can fill in that a because we know an x and a y that it goes through. We know it goes through a 6 and a negative 41. So therefore, negative 41 is equal to a times x minus 6. Oh, do that back. So you're going to get 6 minus 2 squared plus 7. So therefore, you're going to get negative 41 is equal to a times 4 squared. So it's 16 plus 7. So you're going to get 16a. You're going to subtract 7, subtract 7. You're going to get negative 48 is equal to 6a. So you're going to get a equals negative 3. So therefore, we go back into the equation right there, and we make it negative 3. So we're going to get y equals negative 3, x minus 2 squared plus 7. Just replace that value that we just found. This next problem tells us that it has x-intercepts at negative 3, 0, and negative 1, 0, but it has a y-intercept of 0, 2, as the picture says right here. So, in order to do this, we have to back into it by saying, well, if it has an x-intercept at negative 3, it's got to be x plus 3 has to be a factor, and x plus 1 has to be a factor. Now, if we multiply that out, because both of those, negative 1 and 3, would give us 0, they give us x squared plus 4x plus 3. Well, the only problem with that is if we put a 0 in, we're not going to get a 2. We're going to get a 3. So you have to multiply this whole thing by 2/3. So therefore, our equation is going to be y equals 2/3 times x squared plus 4x plus 3. And that'll work for that. That'll give us the y-intercept and still have those x-intercepts. Okay, probably the last one we're going to have time for is try to figure out the time when the ball will be at a maximum height if it's thrown off the top of a building, if its height is measured in meters above the ground in terms of seconds. So the max height, you can see it's a parabolic path. It's going to be negative b over 2a, so it's going to be x is equal to negative b over 2a. That's going to tell us when we're going to have that vertex facing down. So it's going to be negative 19.6 over 2a, which is negative 19.6 over negative 9.8. So it's going to be x is equal to 2 seconds. So 2 seconds, the ball will be at its maximum height. Now, in order to find that height, we have to put 2 back in. So it's going to be negative 4.9 times 4 plus 19.6 times 2 plus 20. Put that all together. 18, 21.6. No, 19.6. 19.6 minus 2 times 19.6. Oh, plus 19 plus 20. So it's going to be 19.6 plus 20, so it's going to be 39.6 meters. And that is our maximum height. Sorry about that confusing there. I hope that helped.